The exhibition that changed everything. Tokyo. IREX 2025. The largest international robotics exhibition on Earth. Over 600 companies from 14 countries. More than 3,000 booths. 26 years of showcasing the future. This isn't just an expo. It's where the robotics industry reveals what's coming next. And this year, something shifted. Humanoid robots are no longer experimental projects. They're practical solutions entering industry, medicine, services, and everyday life. From ultra-realistic androids that eliminate the uncanny valley to rescue robots lifting debris in disaster zones, Japan and its competitors just showed the world what 2025 actually looks like. Here are the most advanced developments that will reshape how humans and machines coexist. Deep Robotics, eliminating the uncanny valley. Chinese company Deep Robotics brought ultra-realistic androids that interact with people in real time. Lifelike facial expressions. Natural movements. Smooth head turns. Deep Robotics specializes in humanoid companion robots with highly natural behavior and appearance. The uncanny valley, that disturbing feeling when something looks almost human but feels artificial, they're solving it. Their androids feature skin textures, expressions, and motion mechanisms specifically designed to minimize that effect. Equipped with sensor systems tracking visitor movements, data processing algorithms adapting responses during interactive communication. These aren't static figures, dynamic models responding to shouts, smiling, turning their gaze, maintaining basic dialogue. The technology, advanced facial servos creating micro-expressions, pressure sensors in synthetic skin detecting touch, voice recognition processing commands in real time. This isn't robotics for factories, this is robotics for human connection. Japanese android Avatar Yui. Japanese engineers presented android Avatar Yui. Developed as part of the android avatar field, focusing not on industrial automation, but on natural human-machine interaction. Yui stands out for realistic appearance and facial expressions. The android's face is highly detailed. Eye, lip, and head movements look smooth and natural. Gestures and poses closely mimic human behavior. Because of this, Yui is hardly perceived as a traditional robot. More closely resembles a living person, especially important for social and demonstration scenarios. At IREX, Yui was showcased as an avatar robot capable of interacting with visitors, responding to prompts, maintaining dialogue. The breakthrough, Yui can be remotely operated. An operator controls it from anywhere, speaking through it, seeing through its cameras. Imagine customer service, where the person helping you is actually someone working from home, operating a physical robot body. That's not future speculation. That's Yui today. Phasianid technology, tactile precision. Phasianid technology showcased two humanoid robots, Tora 1 and Tora 2. Amid dozens of humanoids that simply walk or pose for cameras, Phasianid's robots stood out by demonstrating object manipulation in conditions close to real-world scenarios. Tora 1 was designed for precise handling, showcasing work with soft and deformable objects where exact control of grip force is critical. These capabilities open doors for humanoids in service, food processing, retail, tasks where conventional industrial robots are too coarse. The specifications: nearly 2,000 tactile sensors providing over 7,800 channels of sensitivity. The robot distinguishes pressure, texture, friction, even temperature. It literally feels an object like a human. Tora 2 is positioned as a more versatile humanoid, emphasizing mobility, stability, and operation in unstructured environments, capable of moving through real spaces, corridors, rooms with obstacles, uneven surfaces, all while performing a wide range of tasks including logistics and service assistance. Height adjustable from 145 to 185 centimeters. Movement accuracy up to 0.05 millimeters. This isn't research. This is commercial readiness. Kawasaki's robot ecosystem. Japanese tech giant Kawasaki drew attention not only with industrial robots but with its futuristic concept, Robot Kaleido, a four-legged mobile robot combining characteristics of machine and living creature. Kaleido is not a classic humanoid or industrial automaton. It's a four-legged transport robot of the future, blending machine and animal traits. Developed with focus on new forms of personal mobility and stable movement over rough terrain. Equipped with 4 articulated legs ending in rubber hooves, providing reliable traction on variety of surfaces. Grass, rocks, loose soil. This design allows Kaleido not only to move, but also to adapt flexibly to complex terrain, absorbing shocks, maintaining stability, powered by hydrogen engine. Only exhaust is water. Integrated interface shows stability, fuel levels, even illuminates optimal foot placement spots at night. Kaleido became the symbol of a new direction, robotic personal mobility where human and machine become a single system. You don't just control it, you ride it. Like a mechanical horse navigating terrain cars can't handle. Pudu D5, Industrial Robot Dog. Pudu Robotics debuted its new generation four-legged robot dog, Pudu D5. Autonomous platform designed not for indoor service tasks, but for demanding industrial and outdoor environments. Equipped with multiple cameras with 120-degree field of view. Dual LiDAR system, creating dense 3D map of surrounding space for precise navigation and obstacle avoidance. One of the key features. Ability to autonomously navigate vast areas. The system can build maps and orient itself across sites up to 1 million square meters. Operational range on single charge reaches up to 14 kilometers, making it suitable for logistics, infrastructure inspection, and large industrial complexes. The D5 confidently climbs, slopes up to 30 degrees, overcomes steps up to 25 centimeters, adapts its gait to terrain, vibration, and uneven surfaces, recognizes gestures, responds to voice commands, patrols areas larger than a square kilometer. Payload capacity 30 kilograms. This isn't a toy. This is infrastructure inspection, security patrol, autonomous delivery across massive facilities. Hyundai's MOBD platform. Hyundai Motor Group unveiled its new autonomous mobile robotic platform, MOBD, officially moving out of concept phase. Preparing for mass production. Hyundai's first large-scale mobile robotic platform designed for real-world applications in logistics, delivery, service, and scenarios requiring autonomous movement. MOBD is a compact four-wheeled robot equipped with AI-based autonomous navigation system. Can independently plan routes. Avoid obstacles. Orient itself in surrounding space thanks to combination of LiDAR, cameras, and perception algorithms. Key feature. Eccentric body positioning mechanism allowing real-time adjustment of platform's height and tilt. This means MOBD can climb stairs, navigate uneven terrain, maintain perfect horizontal orientation regardless of ground angle. About 60-70 centimeters long, 50 centimeters wide, only 30 centimeters tall. Despite size, it has active suspension with 3 degrees of freedom on each of 4 wheel modules. Wheels can move up and down, change angle, adjust pressure, almost floating over any terrain. This is a modular platform. It can become anything. Autonomous courier. Food delivery platform. Camera dolly for filmmaking. Lab on wheels. Logistics transport with manipulator for moving boxes. Tubam Industries, the Mecha dream. Japanese startup Tubam Industries showcased one of the most impressive mecha robots of modern times. IREX. Looks like it stepped straight out of science fiction movie. This massive robot stands about 4.5 meters tall. Weighs around 3.5 tons. Truly astonishing in scale and control concept. IREX is not just a static exhibit. It's a piloted robot. Inside its body is a cockpit where human operator can control the machine using joysticks, pedals, and screens. receiving visual feedback from cameras mounted on the robot. This method of control creates a sense of unity between human and machine, as if you're not just controlling it, but living inside your own mechanical exoskeleton. This is the mecha dream made real. Not for combat, not for industrial work, for the pure experience of piloting a giant robot. 2BAM Industries built this to prove it's possible, to inspire, to show that childhood dreams can become engineering reality. Agibot A2, Endurance Champion. Shanghai-based company Agibot drew attention as one of the most prominent representatives of Chinese humanoid robotics. Their most famous robot, A2 model, set a Guinness World Record by traveling over 106 kilometers without stopping, demonstrating high level of autonomy, stability, and navigation algorithms. At IREX, Agibot presented robotic platforms designed for interaction with people and operation in real-world scenarios. Service, logistics, industrial tasks. The A2 has fairly standard specifications for successful market launch. Human-like form, height of 175 centimeters, weight of 55 kilograms, fast joint actuators, stable gait, but the achievement matters. 106 kilometers non-stop, across Shanghai, navigating streets, sidewalks, obstacles. That's not lab performance, that's real-world endurance. Agibot is flagship of young Chinese company founded by former Huawei engineers. In 2 years, the startup went from lab to nearly 1,000 robots already produced. Engineers focus on energy efficiency, fast reaction, robot trained through multimodal models. Understands voice, sees objects, plans actions, executes without rigid programming. Built for 8 areas: logistics, security inspection, exhibitions, stores, offices. Motion capture teleoperation. One of the most memorable booths, Japanese-Chinese team demonstrating technology transferring human movements to physical robot using motion capture and teleoperation. Demonstration revolved around robot replicating operators' movements in real time. Person wearing special suit or sensors moved. Robot synchronously copied every action. Technology developed by Neutum Robotics, known for motion capture and teleoperation solutions. They integrate mocap systems into robotic platforms, teaching robots human movements, allowing them to be controlled like avatars. Thanks to these solutions, robot could easily understand what person was doing and reproduce same movements, steps, bends, subtle manipulations. This solves a critical problem. Programming complex movements is hard. But humans already know how to move. Capture that movement. Transfer it to robot. Now the robot can perform tasks it was never explicitly programmed for. Applications: hazardous environment operations, remote surgery, delicate assembly. Anywhere human dexterity is needed but human presence is dangerous or impossible. The chess-playing cable robot. One of the most unusual demonstrations, chess game where robot moved pieces shaped like beer bottles. Behind this, Japanese company Muscle Corporation showcased lightweight cable-driven robot operating without massive robotic arms. Instead of traditional manipulator, system used taut cables to precisely position gripper over desired bottle. Robot carefully lowered. Grabbed object, lifted, moved to correct square on chessboard. This design allows highly precise movements without bulky mechanics typical of conventional industrial robots. Why does this matter? Cable-driven systems are lighter, faster, more energy efficient, can operate in tighter spaces. They trade raw strength for precision and elegance. Perfect for applications where you don't need to lift hundreds of kilograms. Just need to position objects perfectly. IREX 2025 revealed something critical. Humanoid robots are no longer future technology. They're present technology entering real-world deployment. Ultra-realistic androids eliminating uncanny valley. Rescue robots with superhuman strength. Four-legged platforms navigating terrain. Piloted mechas making childhood dreams real. Japan and China are racing, each showcasing different approaches. Japan emphasizes precision, human interaction, specialized applications. China emphasizes production scale, rapid iteration, commercial deployment. Both are winning. In different ways, the robots showcased at IREX aren't prototypes gathering dust in labs. They're platforms being deployed in hospitals, factories, logistics centers, disaster zones. The future of human-robot coexistence isn't coming. It arrived in Tokyo at IREX 2025, and the world is only beginning to understand what that means. If this look at Japan's robotics revolution changed your perspective on what's possible, hit that like button. Subscribe for more coverage of cutting-edge robotics. Turn on notifications. Question for the comments: which robot impressed you most? The ultra-realistic androids, the piloted mecha, or the endurance champion A2? Thanks for watching. See you in the next one.